Hello there. So far we have learned about the parameters that are used to describe motion. Now we will see the three equations that relate these parameters. These equations are known as equations of motion. So there are three equations of motion that relate these parameters. Let's start with the first equation. The first equation is fairly simple and can be derived straight from the interpretation of acceleration. We had discussed that acceleration is equal to change in velocity by the time taken to bring about that change. Now, we are going to use some symbols which are standard. So let's first look at those symbols. To represent initial velocity, we will use u. So u represents initial velocity, and we will use v to represent final velocity. So v stands for final velocity. A is used for acceleration. T to denote time, and S represents displacement. Now, one thing that you must remember is that all of these quantities except time are vector quantities and they must be substituted with their suitable signs. Also notice that S here represents displacement and not distance. Right. So all these quantities, they are vector quantities and hence must be substituted with sign. Another thing to notice is that we are working under the assumption that the acceleration is constant. Now, you need not worry much about this, but remember that we are working under the assumption that acceleration is constant. Right. So let's get back to the first equation of motion. We know that acceleration is defined as change in velocity by the time. And we have already seen that change in any quantity is defined as the final value minus the initial value. So by the very definition, we can say that acceleration is equal to the final velocity minus the initial velocity divided by time. Right. Now if you rearrange this equation, you can easily come to the expression of the first equation, which is v is equal to u plus at. So this is the first equation of motion, and this equation relates initial and final velocity through acceleration and time. Right. Let's now come to the second equation. For the second equation, we are going to first study once again the average velocity. Now, I hope you remember we have studied that average velocity is equal to the total distance traveled by the total time taken. Right. Now, whenever acceleration is constant, and that is why this assumption is critical, whenever acceleration is constant, the average velocity is simply equal to the final plus initial by 2. I'm not going to prove this. I'll only drop you a hint, that is, think about linear functions. Think about linear functions once you've studied about them in mathematics. We will also discuss this while we are talking about graphs. So, whenever acceleration is constant, the velocity curve is a linear curve, and in that case, average value lies at the midpoint. Don't think about it too much. For now, you can accept this as a fact, that as long as acceleration is constant, we can write the average velocity as the mean of the initial and final velocity. Right. So if that is the case, we know that the displacement is equal to the average velocity into time. Right. Because the very definition of V average is displacement by time, the total displacement by time. So if you have average velocity, you can simplify the displacement as product of average velocity and time. Right. Now we have seen that when acceleration is constant, we can say that the average velocity is the mean of initial and final velocity. So if I substitute this, I get the value that S is equal to V plus U by 2 into T. Now look at the first equation. We can eliminate V by using the first equation. So if I do that, I can write S is equal to U plus AT, this is the substitution for V, plus U divided by 2, the entire thing into T. Now the simplification is simple. U plus U becomes 2U divided with 2, you're left with U. And then you further multiply it with T, so the first term becomes UT. Right. The remaining term is AT by 2. When you multiply it with T, you get AT square by 2. So this gives us the second equation of motion. That is, S is equal to UT plus half AT square. So the second equation relates displacement with time. It does so through U and A, but basically this equation is used whenever you want to find displacement and you know about time. Right. We will understand these better when we do a few illustrations. Now coming to the third equation. So in the third equation, we are basically trying to relate these parameters without including time. Right. So to do that, we are going to eliminate time from the second equation. And how can we do that? We can do that with the help of the first equation. So if you rearrange this term, you could write that time is equal to V minus U by A. So time can be written in terms of V, U and A. And we will substitute this value in the second equation. Let's do that. So S becomes U into V minus U by A plus A into V minus U by A whole square. Right. Once again, there is some simplification to be done. So let's do that. S is equal to, when you multiply this, you get UV minus U square by A plus. Since there is a square, one of the A will get cancelled and you have A into V square. In the numerator, you're left with V minus U whole square, which is V square plus U square minus 2 UV. Right. We've missed out on the half AT square, so you'll have a 2A in the denominator. Right. So take LCM, you see that the LCM is 2A. You'll have to multiply 2 this side. You have 2UV minus 2U square plus the remaining terms V square plus U square minus 2UV. The UV gets cancelled. One of the U square cancels with minus 2U square. Additionally, if I take 2A to the left hand side, I see that 2AS is equal to V square minus U square. So this is the third equation, which is often written as V square minus U square is equal to 2AS. So this is the third equation of motion. So let me label this. This is the first equation, this is the second, and this is the third equation of motion. So these three equations of motion relate the parameters that we use to describe motion. So we will, in the next session, solve a few illustrations based on these equations and see how they help us find out the values that we need. Thank you.